Hi, tonight we're going to take notes on Pythagorean Theorem. So go ahead and get your comp books out and pause the video if you need to so that you're able to get Pythagorean Theorem written down and so that you are ready to take the notes. So we are going to start off with drawing a picture. The picture is going to be of a right triangle. So we have a triangle. And it's a right triangle because it has that right angle right there. A right angle is 90 degrees. To use Pythagorean theorem, it has to be a right triangle. If it's not a right triangle, you cannot use Pythagorean theorem. So it has to be a right triangle. There we go. So we have Pythagorean theorem, and it has to be a right triangle. Now we are going to label the different sides of this triangle. So I'm going to start with this side, and I'm going to label it as A. And then I'm going to have this side, and that's going to be B. Now, A and B actually don't matter. You can switch them, so this could be B, this could be A. Those don't matter. The one that matters is C, and this one is going to be labeled as C. The way that you can tell which one is labeled as C, I like to draw an arrow from that right angle. And C is always across from the right angle. So to tell where that C belongs, you're going to draw that arrow across, and that is where you're going to label C. Now that side has a specific name. It is called the hypotenuse. Hypotenuse is the side across from the right angle. It also has a special property that it's always the longest side. So let's recap what we just talked about. The first thing is we're going to be talking about Pythagorean theorem. Pythagorean theorem, it has to be a right triangle. In the right triangle, you have a 90-degree angle. That's what makes it a right triangle. And then we have A, B, and C. But remember, A and B, it doesn't matter. It could be A and B, or it could be B and A. The only one that matters is C, and C is always across from that right angle. C is called the hypotenuse. So why does all that matter? What Pythagorean theorem is, it is an equation, and it's going to be A squared plus B squared equals C squared. And this right here is super, super, super important. You use this all the time in integrated 1, in integrated 2, and probably in integrated 3. It is super important. It's one of those very, very important things that you learn this year that you'll take with you forever. It also is a very common thing that you can use in real life, like in real life math. So it is a very important concept. So let's go ahead and do an example. And I'm just going to draw a little triangle. I have my right angle. It is a right triangle. And then I'm going to have that triangle. So go ahead and copy it down. And now I know that I need to set up my A squared plus B squared equals C squared. That is my Pythagorean theorem. A squared plus B squared equals C squared. I know that I'm going to need to use that because I'm searching for a side length. Right here is my X. I'm looking for a side length, so I know that I need to use Pythagorean theorem. Now, I'm going to label the parts So I'm going to label A, B, and the most important one is C. Again, I'm going to draw that arrow from the right angle, and that's C. Now I can put that into my formula. This is going to be 3 squared plus B is 4. That's 4 squared equals, and then my C is actually X. And now we square things. Now remember what square is. Square is 3 times 3, twice. It's not 3 times 2, it's 3 twice. So that's going to be 3 times 3 is 9, plus 4 times 4 is 16, equals, we can't do X times X, so I'm just going to leave it as X squared. And then we have 9 plus 16, which is 25, equals X squared. Now, I know you've seen this before in this class. We have X squared equals 25. The way that you're going to solve that, the opposite of a squared is a square root. So we are going to square root both sides to get that squared out of there. So that'll look like this. That's what the square root is, and that gets rid of that squared. So then we have X equals the square root of 25 is 5. Remember what square root is? That means that there's a number that times itself gives us 25, which makes sense that it's 5 because 5 times 5 would be that 25. Okay, I am going to give you 2 examples that I would like you to do, and then submit your answers, and then I will do them after. So let me just get a little situated here. I'm going to leave up my example like that. Okay, so example 1, solve for X. Okay, so go ahead and do examples 1 and 2. All right, so I'm going to start with example 1, and the first thing I'm going to do is I'm going to figure out where my C is. So my C is across from that right angle. I'm going to draw my arrow. That's where my C is. So then it's easy for me to label A and B, and I know I'm going to have A squared plus B squared equals C squared. So that's going to be 8 squared plus 6 squared equals X squared. 64 plus 36 equals X squared, which then is 100 equals X squared. So when you square root that, you're looking for a number that times itself is going to give you 100, and that number is 10. And finally, example 2, again, A squared plus B squared equals C squared. I'm going to figure out where my C is to start. That is my X. It's not always going to be the X, so that's why I do suggest drawing that arrow so that you make sure that you know where your where your C is. And then we have A and B, so that's 5 squared plus 12 squared equals X squared. 25 plus 144 equals X squared. That's 169 equals X squared. And when you square root that, the square root of 169 is 13. All right, let me know if you have any questions on this, and thanks for watching.